here today. 6.1, we are dealing with the normal curve. So one thing I want to point out is chapter 5. What we did yesterday and the day before was we did chapter 5, and chapter 5 was the probability distribution for a discrete variable. Okay, in chapter 6 and beyond, after chapter 6 and beyond, our distribution will deal with a continuous variable. Reminder, the difference between discrete and continuous is discrete is your data is counting, right? You have one person, two people, three people, four people, or one question, so on and so forth. Now we deal with a continuous variable, which is your variable is have an interval in it, right? The time you drive to school, right? The distance you drive or something like that in terms of the interval. So let's take a look at this thing here. Let's take a look at this item, which is, again, the first thing we want to introduce to you guys is a probability density curve. So probability density curve is basically you have some histogram, and if we were to have some histogram and we draw a curve, so in this case, let's take a look at this thing here, which is, remember your relative frequency, right? We can draw a histogram and we have a shape of a curve, which is, remember our three shape of the curve, which is we have a skew to the right, skew to the left, or symmetric, right? Which is, looking at this thing here, this thing is kind of skewed to the left if the graph looking at you. So if we look at this thing here, we call this a probability density curve. So what does this probability density curve hold? In the sense that given whatever the curve is underneath this curve, under the curve, our main goal, as you will see today, is we need to find the area underneath the curve. So the total area underneath the curve will be equal to 1, which is that is the maximum percentage or the maximum probability we have. And again, looking at this thing here, between the area between A and B, between A and B, we say two things, which is one thing, ladies and gentlemen, this three item, as you will see today, this three item, the area underneath the curve, the proportion of the population, or the probability of a random selected, those three items, whatever they ask you, mean the same thing. Pretty much your goal is you try to find what is the percentage of the data underneath the curve, or again, the area, a proportion, the probability. One thing is these two things, they will change it on you guys, but they ask you the same question. Okay, so don't get distracted. Oh, what is the proportion of a population, or what is the probability? It's basically your goal, or it's basically tell you to find the area underneath the curve. Okay, so the other thing I want to point out is this thing here. Because we're looking for the area underneath the curve at a given point, let's say that at this point A, and if I just draw a line at this point A, I cannot, given a single line, we cannot find the area, because just a single line, there is no width to it. Reminder that the area of anything is we have to take the length times the width, right? So if it's just a single line, we don't have the width. And if they don't have the width, we cannot find the area at one point, okay? So it will always be the area between 2 points, point A and point B. Okay, so the other thing is, the reason why they say this is pretty much the same to tell you that to find the area between A and B is the same as to find the area between A and B inclusive. Meaning, again, unlike chapter 5, where we have to find, meaning more than 7, we have to go back to 6, or we have to go at 7, include or exclude the endpoint. This one here, we don't. This in here, whatever the endpoint is, that's the endpoint we're using, because we're dealing with a continuous variable. Okay, so let's take a look at this typical question with your probability density curve. So let's say if I give you this probability density curve, which is, again, looking at this thing here. So we have this probability density curve, which is, again, is divided into 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, and so on, right? So given this thing here, as you can see, they are not symmetric, which is, again, we don't know the distribution of each of them, right? Because the higher peak will have a higher area. But the only thing they give us is this area between 4 and 6 is 0.16 or 16%, right? So this is what they ask you is, what is a proportion of the population is between 4 and 6? So whatever this data is, what is the proportion of population, which is basically what is the area under this probability density curve? So again, they give us the area, which is 0.16, which is the answer here will be just 0.16, which is the area is the same as proportional, right? So same thing go, which is what is if we were to go into this data and select one item. If we try to select one item, what is the probability of this item? What is the probability of this one item that is between 4 and 6, right? Which is in this case, again, the probability and the proportional is the same, which is 0.16, okay? So again, the homework for chapter 5 and 6 is due next Saturday. So again, next week, so it's gonna be next Saturday, just like our previous test, okay? So again, this week, Sunday is your midterm. Next week, your chapter 5 and chapter 6 due on Saturday. And I think July 4th is Saturday. So again, it's due next Saturday. So you have, this week after the midterm, you have your time to do your chapter 5 and chapter 6, okay? So now, question with A and B, how do we find a proportion of a population versus the same as probability of a given variable? And like I mentioned earlier, proportion and probability is the same in this way, okay? So now they ask you, what is the proportion of a population is not between 4 and 6? So we know that between 4 and 6 is 0.16. What is the proportion of population that is not between 4 and 6, which is, reminder, our rule is underneath this curve, the total population, the total area underneath this probability density curve is 1. So if we know the total is 1, and if we know this thing here is 0.16, all we need to do is take 1 minus 0.16 to give us 0.84, which is the leftover of this group of item and this group of item. We don't know how much of the distribution of the probability is, but we know that the leftover beside this 0.16 is 0.84. Okay, so that's the idea here is if we give you a probability density curve, can we look at that? Can you guys look at that and answer the follow-up question? Okay, so similarly, let's take a look at another curve, another abstract curve, which is, again, this is a abnormal curve, or in terms of this is the reverse bell-shaped curve, which is, as you can see, we have some curve, and this one here, they give you the area, right? Given this curve, if they don't give you the area, it will be very hard for you to find the area. You could do it if you know calculus and you can find the tangent of the line and you can find a rate of change in terms of from here to here, how much do they change and so on and so forth. But again, for us, we don't have to do that, right? For us, whatever density, whatever probability density curve they give us, they will give us some area here. Okay, so looking at this thing here, as you will see, one thing I will ask you guys to do is sketch your probability density curve. Is at least it's give you an idea of what area, because later on our goal for this 6.1 is we need to find the area of the area underneath the curve. Okay, so this one here, they give it to us. So let's take a look at the follow-up question. They ask you, what is the probability of a random selected value? We don't know what this data is. We know that this data is 0, 1, 2, 3, 4, 5, right? What is the probability of a random selected value between 0 and 1? So reminder, the area, the probability and proportion of a population is the same, which is looking at this thing here. We know that between 0 and 1, this is the area we're looking for. And if this is the area we're looking for, they have already given to us, which is the answer will be the probability between 0 and 1 is 0.63, right? And similarly, if they ask us what is a proportion of a population between 1 and 2, which is we know 1 and 2 is right here. This is the area that we're looking for. And again, the proportion of the population between 1 and 2 will give me 0.23, right? So again, proportion between 1 and 2 and probability of 1 and 2 is the same. It's just different structure of the question, but the answer is the same, okay? And lastly, they ask, well, not lastly, number C, they ask you, what is the proportion of a population between 0 and 2? So where is my area between 0 and 2, which is, do you agree that this is the shaded area? Those are the area between 0 and 2. And given that, if this is the area between 0 and 2, all I need to do is take the 0.63 plus the 0.23, and that will give me the proportional of the population between 0 and 2, okay? And one thing I want to point out to you guys is, remember, the maximum area underneath the curve is equal to 1. So if they ask you to find the area, if they ask you to find a probability, or if they ask you to find a proportion of a population, your answer should not be more than 1, okay? Because the biggest number you can get is 1. So if they ask you to find the area underneath the curve, the probability or a proportion of the population, the answer will be some decimal, will be between 0 and 1, okay? So similarly, let's take a look at this thing here, which is they ask you, what is a probability if you go in here and you select a number, and that number is greater than 2? Which is, do you agree that this item greater than 2 is anything to the right of 2? Right, the 3, the 4, the 5, or the 2.5, the 3.5, the 4 and 5. Reminder, this is a continuous data, which is you can pick 2.0027, right? So anything above, anything on the right of this thing here is more than 2. So if I know the area to the left of 2, right? If I know 1 and 2, or 0 to 2 is 0.86, do you agree that to find the area, the leftover, I need to take 1, which is the maximum area underneath the curve, minus 0.86. And if I subtract that, I will get equal to 0.14, which is, again, we don't know how much the distribution of each one is. As you can see, as this graph decreases, the area is less and less and less and less, right? Like down here is not even 1%, right? So the more area will be up here, and as it goes, it will be less and less and less. But all we know is between 2 and 5 is 14%, right? If this thing here is 100%, this group of the green item is 14%, but I don't know exactly how is the breakdown, because I don't know the rate of change in this graph here, okay? So let's take a look. Question on this thing here. Question on how to find the area if they give you a probability density curve. Again, probability density is just basically tell you that it's wholesome, you know, the area of something, right? How thick something is, right? So looking at this thing here, again, pretty much the probability, that's why the total area, which is the total probability, is 1. That's why any probability density curve, you will have the total is equal to 1. And one thing is, if this is any density curve, any probability density curve, they will give you the area. You don't have to find the area, right? If you have 3 items like this, if you have three regions like this, they will give you 2 of them, and you just have to find the last one, right? Or if they have 1, or if they have 2, they give you 1, you need to find the other one. Okay, so any question of how to use in this table, or not table, this curve, this probability density curve, to answer this 4 question here. So if you can see, looking at this curve is easy to find, right? They give it to you guys. So now we have this specific curve. We have this specific curve we call a normal, well, it's a normal curve, which is the title, but this is a normal distribution. Or sometimes you hear me say a bell-shaped curve, right? So there is a population that represents a normal curve is said to be a normally distributed or a normal distribution. Okay, basically they tell you that if you have something like this, which is this is a bell-shaped symmetrical curve, and as long as this bell-shaped symmetrical curve, we say that this is, if we have a normally distributed, then this is our curve. And if this is the curve, the breakdown of this curve will be fixed, will have the same area all the time. Okay, and the property of this curve is this, ladies and gentlemen, the probability of this curve is there is only one mole, which is the highest peak is your mole. Remember, the mole is the most value, right? Your value appear up the most. So there is one peak, right? If you in chapter 3, there is bimodal, meaning you have two peaks, right? The other thing is they are symmetric, meaning if we have a mole in the middle, there will be 50% of the data below that mole and 50% of the data above that mole. Okay, meaning they are basically balanced out. They are symmetrical on both sides. And the one unique thing about this normally distributed or normal distribution is this: the mean, the median is equal to the mole. Meaning basically your mean, your median, your mole is at one location. Okay, and that's the unique thing about the normal distribution curve. Okay, so again, one thing is for your regular data, if you try to collect the data, you will not get this normally distributed curve, because your data, again, there will be some extreme and there will be some more and some less. But you know, sometimes we collect a lot of data and it's come out to close to this thing, and we just say, oh, it's close to it, so we say it's normally distributed. Okay, and the last property of this normally distribution curve or normal curve is they follow the empirical rule. So empirical rule, reminder, empirical rule in chapter 3, which is, this is your empirical rule say. It's pretty much tell you that the middle of your symmetrical bell-shaped curve is 0, right? The middle is your mean, your median, your mole. And reminder that if we within one standard deviation, meaning if we go up one and we go down one, which is the same as in chapter 3, which is this is your, kind of review for your midterm one, your chapter 3 asks you using the empirical rule, which is, remember, empirical rule is within one standard deviation from the mean, meaning you go up one, you go down one, it will include 68% of your data. If you go up 2, if you take 2 steps to the left and 2 steps to the right, it will include 95% of your data. And if you go up 3 and we go down 3, if we take 3 standard deviation above within the mean, if we go 3 standard deviation within the mean, then it will include 99.7% of your data. Okay, so one thing about this thing here is, if you remember in chapter 3, the empirical rules say that if we within 3 standard deviation, it will include almost all of our data. Okay, so the only thing different in chapter 6 is instead of say almost all of your data, instead of say almost all, we say 99.7% of your data. And again, the total data is 100%, right? The total data is 100%. And now this thing here include 99.7%, which is kind of almost all, right? There's only 0.3 of the percent left. So again, in your midterm, hint, in your midterm, if they say within 3 standard deviation, then you do not answer 99.7. In your midterm, if it's within 3 standard deviation, the answer is almost all. Okay, the only thing they change in chapter 3 to chapter 6 is chapter 6 we say 99.7. Okay, but one thing is we don't want, we did this already. We did this empirical rule in chapter 3, so we're not going to focus a lot on this empirical rule. As you will see a little bit later that we're not really using empirical rule, we can do it on our own. Okay, so looking at this thing here, the next thing all we have is we have a, if we have a normal distribution curve, we will have a standard normal curve. It's the same thing. It's basically tell you that it's symmetric. The only thing different is a standard normal curve, your mean will be equal to 0, and the spread out of your standard deviation will be 1. Okay, so again, you will see that this mean equals to 0 and the standard deviation equal to 1 a lot later. It just say that every time you see that it state that normal, standard normal distribution, then as long as a standard normal distribution, the mean is equal to 0 and the standard deviation equal to 1. Okay, and again, the other thing we did in chapter 3 was, to recap was we need to convert your data to become a z-score, right? And again, what is the z-score? Reminder, right? On your midterm, reminder, the z-score is basically tell you how far are you from the mean, right? How far are you from the mean? If your z-score is positive, you are above the mean. If your z-score is negative, you are below the mean. And how do we find the z-score? The z-score is you take the data, which is the x, minus the mu, divided by the standard deviation, right? So again, we did this in chapter 3, which is on your midterm. Most likely they will ask you to find the z-score, right? That's in chapter 3. So again, this is the formula that we have. Chapter 6, we're not really focusing on how to find a z-score. We did it in chapter 3 already. In chapter 6, our main goal is we need to find the area underneath the curve between some value. Okay, so again, this thing here just tell you the main key of this thing here is if your data say that it's a standard normal distribution, then you have to remember that a standard normal distribution is your mu, your mean is equal to 0 and your standard deviation equal to 1. Okay, so let's take a look at this thing here. Let's take a look at our goal and our objective for today, which is, again, like I mentioned, our goal and our objective for today is we need to find the area underneath the curve. So in this case, this is what they ask you to do is find the area under the standard normal curve to the left of the z-score of this. Okay, so one thing I want to point out is there is this method which is on your homework. They will ask you to use the table. So if you click on the table, they say table A1, which is for you guys the book, the appendix 2, right? A2, not A1, A2. The appendix 2, we can use that to answer our question. So they ask you to find the area under the standard normal curve to the left of z-score of 2.56. So one thing is this chart, this table, ladies and gentlemen, let me share you my screen. So this table right here, if you click on the table, this is what the table will give you. Or on your homework, your homework, the table is a little bit different from this, but it's the same concept, the same idea. So what is this table represent? The table represent whatever the percentage inside here. This is the percentage from the left all the way to the endpoint. So pretty much if they ask you to find the percentage to the left of the z-score, then the percentage is in here. Your answer is this answer here, whatever your z-score is. So how do we dissect this table? So one thing is looking at this thing here, this is your z-score, which is, again, your vertical item is your 1 place and your 10th place. And your horizontal item here is your 100th place. So my question last time was find the area to the left of 2.56. So 2.56, we go all the way down to 2.5, which is 2.5 is here, right? This is my 2.5 column. And I go to the sixth item, which is again 2.56, which is again, this is my 0.06 item, which is, this is the 100th place, which is, as you can see, this is the answer that I'm looking for here, which is the answer I'm looking for is this item here in the sense of, let me zoom in the sense of